Hello everyone. I hope everyone is fine and doing great. Right. Okay. Today we will continue our discussion on factorization of a polynomial by using algebraic identities. Okay. We have already discussed a few numerical questions in the previous tutorial. We'll continue our discussion on factorization by using algebraic identities. So before we go into the problem solving and solve questions from your textbook, let us quickly revise what are the standard identities we were using and what are the standard identities you should be knowing. Okay, so these are the three standard identities which I have already written it down for you. The first standard identity being a plus b whole square is equal to a square plus b square plus 2ab. The second one being a minus b whole square is equal to a square plus b square minus 2ab. And the third one, a square minus b square is equal to a plus b multiplied by a minus b. Well, this is not something new for you. We have already discussed this. We have already applied this in the previous tutorial also, when we solved a few questions, question number 1, 2, 3, 4 and 5. Okay, so this is just a revision that these are the standard identities we'll be using today also. Okay, now today I will take one question number 7 Roman 1. Okay, in the previous day, in the other day, we were solving questions from exercise 11.3. So today also we'll continue solving questions from 11.3. So I'll take question number 7 Roman 1. Okay, question number 7 Roman 1, exercise 11.3. This question is on page number 218. So question number 7 Roman 1. The question reads as 25 into a plus b whole square minus 16 into a minus b whole square. So if we look at this sum, we can see that the bracketed term is already in the form of square and square. Okay, but what about the numerical? Okay, we have 25 and 16. It is not expressed in the term of square, but at the same time 25 is also a perfect square and 16 is also a perfect square. So we can write 25 as 5 square and we can write the 16 as 4 square, if you can see in this step. Okay, so 25 can be written as 5 square and already we have the a plus b whole square, and 16 can be written as 4 square and already we have the a minus b whole square. Okay, now we can see that we have a square here, we have a square here. So we can give a single square. We can just write down both these terms inside the bracket and we can give a single square to both the terms. So which means 5a plus b whole square. This square is applicable for the 5 also, and this square is applicable for the a plus b also. In the same way, 4a minus b, so we can put the 4 and the a minus b inside the bracket and then a square outside the bracket. So this square is for the 4 also, and this square is for the a minus b also. Okay, now we can multiply the 5 inside the bracket. So what does that mean? So 5 into a will give us 5a and 5 into b will give us 5b, and 4 into a will give us 4a and 4 into b will give us 4b. Okay, now if we can see, this is in the form of a square minus b square. Okay, so 5a plus 5b, this whole thing acts as our a square, and 4a minus 4b, this whole thing acts as our b square. So this is in the form of a square minus b square. So what is our formula for a square minus b square? Our formula for a square minus b square is equal to a plus b multiplied by a minus b. Okay, so from here we will just apply the formula a square minus b square is equal to a plus b, a minus b. So what is our a? 5a plus 5b plus b, 4a minus 4b. So this becomes a plus b and then a minus b. That means 5a plus 5b minus, wherever you have a minus sign you have to be very careful. Then we can just write it inside a curly bracket because already we have used the common bracket. Okay, so this can be written as this way. Okay, so 5a plus 4a, this will give us 9a. 5b minus 4b will give us 1b or simply b. Okay, now here, since there's a minus sign here, okay, this minus sign will multiply inside the bracket. Okay, so let us multiply the minus sign inside the bracket. So 5a plus 5b, then this will become minus 4a, minus into minus, plus 4b. Okay, so this gives us 9a minus b multiplied by 5a minus 4a will give us a, and 5b plus 4b will give us 9b. So this will be our factors for 25a plus b whole square minus 16a minus b whole square. Okay, so we have used the standard identity, a square minus b square is equal to a plus b into a minus b to factorize this polynomial. Okay, I think the working is clear to you. Okay, now let us take one more question, question number 8 Roman 1. This I have solved question number 7 Roman 1. So 7 Roman 2, since 7 Roman 2 is similar to this, 7 Roman 2 will be your assignment. Okay, I'll just give you the assignment at the end of the tutorial. Okay, now let us check question number 8 Roman 1. Okay, so let's write down the question first. Question number 8 Roman 1, the question reads as x cube minus 25x, x cube minus 25x. So we need to factorize this polynomial. So if we observe, the first term is not in a perfect square, neither the second term is in a perfect square. So the first term is given as x cube. Okay, it's not square, it is x cube. That means in order to make it as a perfect square, we need to take one x outside. That means we need to remove one x, so that this will become x square. Similarly, if we remove this x, then this will also become 25, and 25 can easily be expressed as 5 square. So what is the basic concept in this? We need to take x as common. Okay, what is the profit of taking x common? Okay, this will profit us that this x cube will become x square, and this 25x will become 25. So this will become whole square, and 25 can be written as 5 square. So the resulting terms will be in the form of a square minus b square. So what is the common factor we need to take? We need to take x common here. Okay, so let us take x common. So after taking x common, what will be left over? X cube will become x square minus 25x will become only 25. Okay, so this is equal to x goes outside, this is x square minus now 25 is nothing but our 5 square. So instead of 25, what can we write? We can write 5 square. Now if you notice the terms inside the curly bracket, it is already in the form of a square minus b square. So the x we can write it here, and then a square minus b square means a plus b multiplied by a minus b. So what will be the factors of this polynomial? X multiplied by x plus 5 multiplied by x minus 5. Okay, so this will be the factor of the polynomial x cube minus 25x. Okay, so the main important thing you need to be careful here is taking the x common. If you take the x common, the resulting will automatically be in the form of a square minus b square. Okay, now question number 8 Roman 2 is also similar, wherein you need to take one numerical as common, and then the resulting terms will directly be in the form of square. So 8 Roman 2, I'll leave it up to you as your homework. Okay, now let us discuss one more type of question. This is a new type of question, question number 10 Roman 1. So let us solve question number 10 Roman 1 and see how do we go about it. Okay, so let's discuss question number 10 Roman 1. So if I am to write the question number 10 Roman 1, the question reads as x square minus y square minus 2y minus 1, x square minus y square minus 2y minus 1. Okay, now we need to factorize this. Okay, now please pay attention here, please be very careful here. So what will we do here? X square, okay, if I take a minus common for all the remaining three terms, okay, the last three terms, what happens if I take a minus common for the remaining three terms? So what will we get? If we take a minus common, the sign of all the three terms will change. That means minus y square will become plus y square, minus 2y will become plus 2y, and minus 1 will become plus 1. Okay, now whether we are correct or not, how can you check? You can just multiply the minus inside the bracket and it will give back the same question. Okay, let us check. So minus into plus minus y square, minus into plus minus 2y, and minus into plus minus 1. Okay, so x square minus y square plus 2y plus 1. Now the first term is already in the form of x square, that means a square minus, now this we need to write in terms of b square, so that we can easily apply the identity a square minus b square. Okay, let us see how do we change this to b square. Okay, now please be very careful here. X square minus, okay, can this be written as y square plus 2 into y into 1 plus 1 square. Okay, let us check whether whatever we have written is exactly the same as whatever was there in the question. We are not allowed to make any changes to the question. However, we can write it in a different format. Okay, we can manipulate and we can write it in a different format. However, we are not allowed to change the values or to make any changes in the main question. It should result in the same question. Okay, let us check whether whatever we did here is exactly the same as this or not. Okay, let us check. Y square, we have y square. Now 2 into y is 2y. 2y into 1 will give us 2y, so we have the 2y here, plus we have written this as 1 square, and 1 square is nothing but 1. So whatever we have written here is nothing but the same as the question here, y square plus 2y plus 1. Okay, now after this, why have we written this? Okay, if you closely observe, we can see that this is in the form of a square plus 2ab plus b square. A square plus 2ab plus b square. So what is our a square plus 2ab plus b square? It is nothing but a plus b whole square. So this can be written as x square minus a plus b whole square. That means our a plus b whole square. So if we expand this, you will get exactly the same thing. Okay, if you expand this, you'll get exactly the same thing. So we are using the algebraic identity in the reverse order. Till now we have used y plus 1 whole square as y square plus 2y plus 1, but we are using this in the reverse order. Okay, now what is the purpose of doing this? If you closely look at this, we see that this is in the form of a square minus b square. A square minus b square. So what is our a square minus b square? A plus b, because this is our a and this entire thing is our b. A plus b multiplied by a minus, whenever you have a minus sign, you have to be very careful, a minus b. Okay, so the first bracket is perfectly fine, x plus y plus 1. Okay, now the second bracket, since we have a negative sign here, we have to be very careful. So what will this become? X plus into minus minus y, and plus into minus minus 1. Okay, so can we simplify it further? No, I think we cannot simplify it further. So this will be our final answer, x plus y plus 1 multiplied by x minus y minus 1. So this will be our factor for x square minus y square minus 2y minus 1. Okay, so I believe that the most important step of this entire sum are these two steps. Okay, so these two steps are the most important steps of the entire sum. Okay, wherein we have manipulated the second part of the question as y plus 1 whole square. Okay, so I hope the solution to this question is clear to you. Okay, so let us take one more example. Let us take one more example of a similar type, similar to question number 10 Roman 1, so that the concept becomes very clear to you. Okay, so I would take question number 11 Roman 1. Okay, question number 11 Roman 1 is quite similar to question number 10 Roman 1. So the question reads as 9x square minus y square plus 4y plus 4y, sorry, it's minus 4. Okay, so let's check our question. 9x square minus y square plus 4y minus 4. Okay, so we need to factorize this. So if we closely observe the question, we can see that the first term is somehow given in the form of a square directly, because 9 can be written as 3x 3 square, and the x square is already in the perfect square. So this whole thing can be written as 3x whole square, but we need to do a little bit of working for the second part. Okay, let us see how do we go about it. Okay, so this is equal to let us write down the 9 as 3 square and the x square as x square. We take a minus common as we did in the previous question. After taking a minus common, what did I tell you? The sign of all the terms will change, the bracketed terms will change. So minus y square will become plus y square, plus 4y will become minus 4y, and then minus 4 will become plus 4. Okay, now 3 square x square can be written as 3x whole square. This can be written as 3x whole square minus, okay, now let us write it in such a way so that this directly fits in a formula. Okay, so y square minus 2 into y into 2 plus 2 square. Okay, now quickly let us check whether whatever we have written in this line is exactly equal to the question or not. Okay, let us check. Okay, y square is y square, perfectly fine. We have to get minus 4y, so we already have the minus. Now we need to get the 4y, so 2 2 is 4, 4 into y gives us 4y, so we already have the 4y here, and we need a 4 here, so 4 we are writing as 2 square. Now what is the purpose of writing this? The purpose of writing this is, if you see, this is in the form of a square minus 2ab plus b square. So what is your a square minus 2ab plus b square? This is nothing but your a minus b whole square. Okay, so let us write it down. So this means this is 3x whole square minus, this means y minus 2 whole square. Okay, if I expand this, I will get back the same thing. That means y minus 2 whole square. If I expand, I'll get back the same thing. This is in the form of a square minus 2ab plus b square. So ab, so a minus b whole square. Okay, so this is in the form of a minus b whole square. Okay, now if we see, this is in the form of a square, this is in the form of b square. So what is our a square minus b square? Our a square minus b square is nothing but a plus b into a minus b. So a plus b multiplied by a minus b. Whenever you have a negative sign, you have to be very careful, because the sign inside the bracket will change. Okay, so you have to be very careful here. Okay, so this will become 3x plus y minus 2 multiplied by 3x minus into plus minus y minus into minus plus 2. Okay, can we simplify it further? No, we can't simplify it further. So this will be our final answer, 3x plus y minus 2 into 3x minus y plus 2. So these are the factors of 9x square minus y square plus 4y minus 4. Okay, so these type of questions are done in a similar fashion. Okay, so based on the workings of whatever we have done in this tutorial, I will give you a few sums for your assignment. Okay, so please make a note of these questions. The first question will be, okay, this will be your homework, your assignment. Question number 5 Roman 2. Then we have question number 7 Roman 2. Then we have question number 8 Roman 2, question number 8 Roman 2, and then we have question number 10 Roman 2, question number 10 Roman 2, question number 10 Roman 2, and then question number 11 Roman 2. So all the Romans 1 I have done, and all the Roman 2 of question numbers 5, 7, 8, 10 and 11 will be your homework, because the working is similar to whatever Romans 1 I have done. Okay, so these questions are from exercise 11.3, and these questions are on page number 218. Okay, so these will be your assignment for today. I hope the this concept whatever we discussed today is clear to you. Well, anyways, if you have any doubts, you can please clear your doubts when we are having our online classes. And if you have any doubt with any of the concept, again you can go back and you can rewatch the video once again. And even after that, if you don't understand, so please raise your doubts when we are having our online classes. Okay, so I hope this tutorial will be helpful for you. Please take care of yourself. Bye for now.